Start the recording. By the way, if you want to turn off your camera, you can. It's no problem. All right, notes 6.4, the last section for Unit 6. We're going to talk about algorithms. And here it is. What is an algorithm? An algorithm is a process or set of rules to be followed in calculations or other problem-solving operations, especially by a computer. It's kind of like a list of instructions, or it's like almost like a recipe. You could say the algorithm for making a peanut butter sandwich is to get out 2 pieces of toast, lay them flat on a counter, and then get out the jam. And you'd have a bunch of rules, like this is how you do it. And what's good about computer science is that there are a lot of things that people have already figured out. So we as you guys as learning this, and anyone coming new to Java, you don't have to learn, you don't have to invent from scratch everything, because people will be like, oh, here's a good way to do such and such, So there's standard ways to work with arrays, and we might as well not have to reinvent the wheel. So today we'll be talking about some of them. Here's a list of all the different algorithms that the College Board wants you to know how to do. The underlined items are ones we're going to do today in our, A, B, C, D, E practice. And then some of these things we already did. So I wrote that down. Determining a maximum or minimum value, we did that last class. Doing a sum or an average, we did that last class. Access all consecutive pairs, we did that last class. Determine how many elements meet a specific criteria, we did that last class. But I'm not putting all of these on our Unit 6 test next Friday, but we'll get to them, Anyway, you'll have this slide deck later. I wanted to walk you through, I forget if I'm doing 2 or 3 different ones of these algorithms that we haven't done yet. So we're going to talk about checking for duplicates. So take a look at this code. To check for duplicates in an array that's not sorted, it'd be one thing if the array was sorted, you could just check, hey, is the next element the same as the current element, right? I mean, that wouldn't be too hard to check for duplicates, just a simple for loop. Hey, is the next one equal to the current one? Hey, I found a duplicate. But let's say the stuff's just randomly thrown into some array. To find if there's a duplicate, you have to pick one element, and then you have to check if any of the other elements is equal to that one. And the easiest way to do that is that I know of is to use 2 for loops. So often it'll look like this. So take a look at this code. The first line is I'm pretending we set up an array full of data. And then I made a Boolean variable called found dupe and set it to false. And then at the end of this process, we'll print out that variable. And if it's false, that means there were no duplicates. And if it's true, it means that we found a duplicate. So let's look at this for loop. The first one, the I declaration, that's going to go, I is going to go from 0 all the way up to 1 less than the length of the array. So in other words, that's going to access every single element in the whole array. And then the next line, we start with a different variable, j, and we start at 1 higher than where I was. So if I is the first element, element 0, j starts at 1. And this is so you don't check an element against itself, right? If you checked element 0 and then you checked, is element 0 equal to element 0? It'd be like, yeah, bing, 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 found a duplicate. So instead of having that problem, we're checking element 0 and comparing with elements 1 through the end. And that's what this code does. The j variable starts 1 higher than I, and it goes all the way up to the end and checks, is that I equal to anything? And then if it did find one that was the same, then it sets that flag variable to true. And that way, you notice that's not an if else, like it doesn't set it back to false inside the loop. We're just setting it false up top, and we're going to run this code. If it ever finds a duplicate, it sets that thing to true. And at the very end, if the variable's true, then we know that we found a duplicate. So this is one way to do it. Any questions? You'll have a chance to practice this today. So one thing I wanted to point out, in code like this, the variable found dupe is called a flag variable, in that you set it to a value and then you do a bunch of stuff. And then after the stuff is over, you can check the value of the variable. So it's like a flag, like, it's like in soccer, there's the linesman. If they see a foul close up, they hold up a flag, like, hey, I saw a foul, or somebody's offsides, or in football, throw a flag that there's been a foul. It's a similar sort of flag concept. So I just wanted to highlight that for you there. If you're in a method, there's a different way. Sometimes you're asked to check for duplicates in a method, and I want you to see this. Here's a method I wrote. This method is called dupe checker, and it receives an integer array, and it has the same two for loops. We've got one that goes from 0 all the way to the end, and the second one starts, the J loop is always one more than the I, goes all the way to the end. And if it finds a dupe, it just says return true. And this is kind of a neat thing about a method. The method's code stops executing as soon as you have a return call. So what happens is this way of doing a duplicate check technically probably be a little bit faster because it doesn't have to go through every single element. If it finds a duplicate, it stops executing, it returns true right away. So there's no need to have like a flag variable in here because it just ends. The code stops running when it gets to that return true. We do have to have the return false. See, that's after all the for loops are done. So in this case, if the for loops are running and they run through absolutely every combination and they never find a duplicate, then it gets to that return false. And it says, yeah, no duplicates. All right. I wanted to show you another algorithm for reversing the order of an array. So you might have an array and you're saying, hey, I want the array to be exactly reversed. So in this case, I made it do it with a string array. So this is going to return an array that's just like the first one, the one that got sent to it, except in reverse order. So this method is receiving a string array called data. And what I'm doing here is I'm creating a new array called temp that is the same length as the one called data. So I create a new empty array. And then this for loop says, hey, temp I is equal to, and this is a little complicated looking, but what this does is it takes, let's say I is 0. It says, I'm going to set temp item 0 to be the last element in the data array. And we know it's the last element because it's data.length -1. Because remember, if it's 10 units long, the last element is element 9. And then -I. And this way, when I is 0, the first element of temp becomes the last element of data. And then when I is 1, the second element of temp becomes the second to the last element of data, and so on. So there's other ways to do this. I think I even show you another way to do it, but this is handy. Like, it's pretty easy to reverse an array if you can just make a new array and then put all the things from the first array into the other one in reverse order. It's not, that's a nice way to reverse an array. So I say the magic is in this highlighted line, and I think I show you a picture. Yeah, awesome. So back to here, this is the line that does all the tricky stuff. And what we're doing is when I is 0, the code sets temp 0 to data 5 - 1 - 0, which is data 4. And then, so that moves the 25 over here. Now, technically, these all should have been empty. Let me just fix that. Oh, no, I can't. It's a screenshot. Oh, well. And then when I is 1, the code sends temp 1 to temp 3, and so on. I'll fix this later. I have to change the picture, and it's Yeah, the only thing wrong is that these values are not actually present yet, and these are not present yet. Shoot. That's okay. Watch this. I'm just covering those things up. How about that? White. There we go. It's not perfect, but it's better than being totally wrong. When you're in trouble, paint over the thing that's wrong. Oh, and this arrow is from way up there. There we go. All right, much better. It's not perfect, but it's better than it was. Questions? So here's the same process, but not using a method. So we have this string array called data, and I'm saying it's got a bunch of stuff in it that's appropriate. Then we make a temp array that's the same length. And then we go do the exact same thing here. And then at the end, we say, hey, data equals temp. And that just replaces the original array with the temporary one that we just made that has a reverse order. So there's another way to do it, the reversing the order, and that's by not using a temporary array, but instead only going through half of the values and then using a temporary placeholder variable. So check this out. We have a string array called data, and our for loop starts at 0 and just goes up to half the length of the array. And so we'll take item 0 because I is 0 first. We say, hey, we've got this temp variable called num, and let's make it equal to the thing at data 0. Then we're going to replace data 0 with the one at the end. And then we're going to replace the one at the end with the temp variable. So we just hold a variable aside, take the one from the end, put it in the beginning, and then take that one from the side and put it in the other spot. So it swaps the elements one at a time. And the reason that we have to do this by divided by 2 is I've personally run into this. If you have an array and you're taking the first element and the last element and swapping them, great. Then you go up 1 and you go back 1 and you swap them and you go up 1. And if you do it all the way through, you actually put everything right back where they were to start with. Like if you go all the way to the end, you end up putting everything back the way it was. Because by the end, you're back at the end and you're swapping it with the first one and you're back to like the original array. So anyway, when you're going to do it this way with a temp variable instead of a temporary array, you have to remember to only go through half of the numbers. Questions? It's a little scary, but you'll get to practice. In fact, you'll get to practice now. I will post these. The rest of the period, I have 5 practice problems. That's because I like to grade 36 times 5 things whenever I can. That's 180 projects. Sorry. It's just 5 for you though. The problem is in past years, I would put all these things in one thing, but then what if you only got half of them done? Do you turn it in? Do you not turn it in? This way you can just, you can do A, you can turn it in, you can do B, you can turn it in. If C throws you off, you could just skip to D, and so on, that sort of thing. So I do want to remind you, if you're struggling, I would watch some of these AP Classroom videos. I did watch them all on Monday. And then here's another thing you can do for practice. You could go back to Coding Bat and do some of the problems we've done already. Like you already have the answers. So just go to Coding Bat, log out so that you don't have your answers, and then try them again. It's a great way to practice.